When thinking of the national parks, our mind sends us on a journey to some of the most iconic vistas in America. But below the surface lies an unseen world. These are the cultural and scientific treasures that make up the underwater wonders of the national parks. December 7th, 1941. As the early morning sun broke over the Pacific Ocean, Japanese planes and battleships made their way towards the small island of Oahu, home to one of the United States' most vital naval outposts, Pearl Harbor. What followed was a 90-minute attack that would alter the course of human history, leaving in its wake thousands of casualties and a mourning nation ready to engage in war. The USS Arizona, a city at sea, was in port on the morning of December 7th. The ship's crew of 1,511 fought valiantly, but could not withstand the attack, as bomb after bomb plummeted from the Japanese planes. A decisive hit sank the 600-foot-long battleship, killing 1,177 sailors and Marines. Only 334 survived. Today, the USS Arizona Memorial is one of the most visited monuments in the U.S. But much has happened to the wreck in the 75 years since meeting its fate. And it is part of the National Park Service mission of science and stewardship to maintain this monument of American history, as well as document its impact on the surrounding marine environment.
What we're doing is we're looking at new ways that we can communicate the physical remains, the touchstone of the Arizona, to the public. And most recently, we've started on a partnership with Autodesk and some other partners to basically virtually map the USS Arizona.
So the project here at the memorial was really about creating a baseline data set, or conducting a really accurate survey of the ship, because that had not happened in 30 years, not since the mid-'80s. So the project involved using a number of different technologies that, frankly, had never been combined before.
The National Park team and their partners have made it their goal to preserve this historic national monument for future generations. The critical and unprecedented 3D scanning of an underwater shipwreck was no easy task.
So during the capture phase, the mission was to capture the entire ship. Everything we could see, everything we could access, every part of the ship that would fall into that field of view, depending on whether it was LiDAR, sonar, or photo. In terms of people in the water, we had a lot of divers. We had divers with cameras taking care of photogrammetry. We had divers manning the diver portable sonar, and then we had divers in the water to maneuver the subsea LiDAR, the underwater laser scanner, because it was really big. This thing weighed 250 pounds, really large tripod. So you can imagine trying to maintain buoyancy and managing this huge thing underwater. It was a real challenge, but it worked.
So using a host of technologies such as side scan, LiDAR, laser scanning, and photogrammetry, what we've been able to do is create a model of the Arizona in three-dimensional space. We take that model and that allows us a whole range of both management options to look at deterioration and structural collapse, but it also offers a unique opportunity to connect people, today's generations, with the past through either looking at the ship or the artifacts that are still on the deck. It's a really interesting way to view the current remains of the ship as it is 75 years after the sinking.
So the end result of all this data is a fabulous three-dimensional georeference data set that's accurate plus or minus anywhere from about a fraction of a millimeter up to about 3 millimeters. So it's pretty much unprecedented. And then finally, when we have this really rich three-dimensional data set, well, so what? You know, how can this be used? Well, we can 3D print it.
The 3D model, with a pinpoint millimeter accuracy, has brought the underwater monument to life. Details not seen from above the surface for over half a century can now be studied in depth, allowing visitors and researchers alike to experience the Arizona like never before.
One of the things that I learned or noticed from the 3D print of the ship is up on turret 1, where the three 14-inch guns are, on either side of the turret there's these huge cracks and collapse of the decking. This is due to this catastrophic explosion that occurred here in the bow and blew forward. But you really couldn't see it. You really can't get a feel for what 1 million pounds of ammunition all lighting off at once can do to a battleship. But you can definitely see that when you put your eyes and your hands on the print of the ship. This data set will now serve as a baseline for future surveys going forward forever. We know exactly what this ship and the building looks like, so that people years from now, centuries from now, can come back, survey again, and overlay and look for change. What's going on out there? Is a crack expanding? Is it contracting? Do we need to worry about an oil release? Because obviously this is hallowed ground. It's a war grave. I mean, the whole reason the Park Service and the Navy look after this site is for that reason.
While the success of the ship's exterior scan provides a wealth of information, the inside of the ship is a much different story. The decisive blast to the Arizona's bow and the ensuing salvage operations have made the interior impenetrable to divers. A remotely operated vehicle in the year 2000 provided human eyes with a glimpse of the first, second, and third decks. Everything below remains a mystery.
One of the issues that we have with the Arizona is you have half of the ship that's destroyed. You can't send a remotely operated vehicle into it. You can't kind of examine that. You can only look at it from the outside. The stern of the Arizona actually is relatively intact. We're interested in using remotely operated vehicles to go inside the vessel so that we can kind of do an interior condition assessment.
The National Park Service, in conjunction with the Woods Hole Oceanographic Institute, are here to test an ROV, that may provide clues to many of Arizona's unanswered questions.
We adapted kind of an existing ROV to our needs that we had. It has to be as small as possible. One of the requirements for the vehicle in order to go into the USS Arizona was that it need to be able to fit through an 18-inch diameter opening. So in order to achieve that, we had to really break this down and make it nice and small. We removed a lot of cabling that would normally interconnect the different components to carry as much payload as we're doing, the amount of cameras, telemetry system, power that's required. It's making it a pretty tight package to get everything housed like that.
If the prototype ROV's initial test runs are successful, a second expedition will begin preparations to breach the unexplored decks in the coming months, providing a glimpse of areas that have been left unseen in 75 years.
And along with that visual survey, we can actually carry a payload on the ROV of a dissolved oxygen or salinity, or all of these environmental parameters help feed into what we know about the ship and help feed into what the potential corrosion is. And all of that extrapolated out will give us an idea of how long the Arizona will last. But the other thing from an environmental standpoint is Arizona still has quite a bit of oil in it. It was filled to capacity right before the attack, so we estimate, based on the amount of damage to the ship, there's still 500,000 gallons on the Arizona.
At the time of the attack on Pearl Harbor, the USS Arizona held approximately 1.5 million gallons of oil. Following the bombing, the ship burned for 2.5 days. Today, half of the oil is believed to still remain on board, and an estimated 2 to 9 quarts of oil leak into the surrounding waters each day, creating a potential hazard to the marine environment surrounding the ship. With scientific data suggesting that the Arizona's structure will survive another 100 years, avoiding an ecological disaster and maintaining the monument are paramount to the National Park Service.
And people always ask us, well, how come you don't just pump the ship out? Well, the problem is on a battleship such as this, there's no one singular gas tank. It's not a tanker. It's a battleship. So each one of these oil compartments were compartmentalized in case they took a torpedo hit. So you essentially have almost 200 bunkers. So, and those bunkers, to make it even more complicated, are actually below the waterline. So you'd have to excavate down through the sediment. You'd have to basically totally destroy the ship, and you'd have to remove what we think we could remove some of the oil, but certainly not all of it. So oftentimes what we say is if the USS Arizona was any other ship in any other harbor, removing the oil could potentially happen. But because it's here and because it's still the resting place of sailors and Marines, it's really not something that we're interested in removing the oil at this point.
The most unique and critical aspect of the prototype ROV is its custom-built tether spooling system.
So one of the things we've been working on is creating a ROV that actually lays the tether as it goes. So now you have a system where the ROV can move wherever it wants to go. It just spools out tether as it proceeds deeper into the ship. And then when you want to simply retrieve the ROV, you fly it in reverse and you actually pick up the tether as you go.
The innovative system reduces the chances of free-floating cable being caught by debris and other obstacles as it traverses through tight quarters and hallways, giving the ROV a chance to explore beyond the third deck for the first time.
By changing the voltage, bringing it over to fiber, we were able to take a tether that was typically over 1/2 inch in diameter and drop it down to under 1/4 inch, which is a lot more flexible. It enables us to, even if we were just pulling it in the wreck, it's an easier tether to manage.
A few years back, they had a lot of difficulty getting the vehicle out of the ship, mainly because of tether management. It took them several days to get the vehicle out, from what I understand. We don't want any risk of that at all because we could never get the vehicle back. We just have to cut it free and leave it there.
Pearl Harbor Control, National Park Service, Boston Whaler. Request permission to transit from USS Arizona Visitor Center to the memorial.
We're heading out to the memorial to test the ROV. So we're going to put it in the water, get it trimmed out, make sure that portion of it is working.
Let me get going. All right, I'm going to swing around.
At the monument, the Park Service team readies the control room and makes last-minute changes to prepare the ROV for its initial test dive.
Just getting the topside system set up for the ROV test. We've tested everything individually, but this is the first time we're sort of getting everything up and working together.
One of the most challenging things about working in the marine environment is putting electricity and electrical components into the water. So we've come with a prototype ROV that we think is going to work on the inside to see how we can maneuver in these small hatchways, these small hallways, and all of that is going to feed into building the system that we can build off of this prototype so that we know the spaces that we can access and go inside and look at the condition of the ship.
After days of hard work, the ROV is ready for its inaugural mission. But things don't always work out as planned.
Oh, no, it's coming back. I think it is. Grab it. I think it's coming back. Is it?
Problems with the thruster and power source have made matters more complicated than anticipated.
Only the starboard.
Yeah, that's why I'm turning.
Did you unplug the port thruster when you unplugged the light?
No, but it doesn't mean it didn't come apart.
Well, the process is you fix one thing and then another thing breaks. So that's what we're working on now. Now the thruster's not working.
And with precious sunlight disappearing, the team must now find a solution.
That can't have sparked.
I hit the... Well, it's certainly par for this course.
A meticulous examination of the ROV reveals the problem. The electricity originating from the monument, responsible for powering the vehicle, is not grounded, causing parts of the ROV to short-circuit in the water. Equipped with the new knowledge, the team makes the necessary modifications to ensure a successful dive.
It's just...
That looks good.
Yeah. So we're just going to send it down, make sure it's good, and that it still has all its buoyancy. And Brett will take it over to the stern.
There's a hole in the back deck. It's a cut hole where the crane used to sit, and there's kind of a triangular space there. So we could kind of feed the ROV in through, and from there we could go down a hallway. We'd move forward on the ship, and we would have the Division Marine office and the Flag Secretary's stateroom are on both sides of the hallway there.
Tell him I see 2 portholes. Or I think they're portholes.
Each one of those cabins have features that are actually pretty similar to each other. There's a writing desk that has a fold-down writing top table, and then next to the desk in each cabin is a white porcelain sink. That actually looks like all of these features are in the floor, but they're not. There's so much sediment built up in the area that it appears that though they're resting on the floor.
In one of the cabins right now?
Yeah. If there's a phone on the desk, that's the Admiral's cabin.
One of the cabins next to the writing desk actually still has a rotary phone that's sitting on a table. It's just there like it was in 1941.
I mean, this is the first time Mike's ever flown this vehicle as configured, so we're just trying to spend a few minutes learning how to fly it.
Well, that tether spool that's sitting on the back of it is a lot of mass, so trying to turn and get it to move the way you want, it doesn't really want to do it that easily. So that's one thing right now, is just getting used to the way that works. It's blocking a lot of the thrust. It's a big weight sitting on the back of the vehicle. There's actually a mirror in there that we came face to face with. See the lights from the vehicle reflecting in that mirror. There's a lot of growth on everything, so it kind of makes for an interesting, eerie kind of image.
The imagery filmed by the ROV is the first ever obtained in high definition. And with a successful run under its belt, the National Park Service will now refine the tether system and the vehicle size for an in-depth exploration of the Arizona on the 75th anniversary of its sinking. What lies below the third deck is still a mystery, but tests have already confirmed a lack of oxygen in the lower decks, suggesting a remarkable degree of preservation that would provide new insights regarding the ship.
And kind of makes you understand what we're here to commemorate, what these individuals suffered, what they went through, and what that period was about, and the things that transpired here. Just to be able to see that. Every inch of it is new to me and novel and interesting and kind of buried in my memory now, that I'll be able to go back for the next several days and just process what we saw here today.
I don't think I will ever look at a data set in the same way again. This is the first point cloud I've seen with a soul that, your laptop screen doesn't look the same anymore. And that story and that legacy and world history that began right here, right over my shoulder, remember that. Remember what happened here.